In this video, we will continue our review of important topics from Calculus 1 by reminding ourselves of what a derivative calculates. So what we saw in Calculus 1 is that a derivative tells us something that is both the slope of a tangent line as well as an instantaneous velocity, or more generally, an instantaneous rate of change. Now, from a definition perspective, we can think of the derivative as being defined as follows. So for a function f, the derivative is another function f prime, which is the limit as h approaches 0 of this difference quotient. The process of finding a derivative is something that we call differentiation. And remember, the value of a derivative at a point is the slope of the tangent line to the graph of the function at that point, which we'll see in a future video through a couple examples. Now, using this definition of the derivative, the limit of the difference quotient, something we spend extensive amount of time dealing with in Calculus 1 is both tedious and time-consuming. And it's really difficult to evaluate as we increase the difficulty of the functions. But we are lucky that there are several formulas that allows us to directly calculate the derivatives more analytically. Several of which are listed here. I'll let you pause the video to study them, but the three most important ones: the power rule tells us the derivative of x raised to a number is that number x to the n minus 1, and then the product rule for differentiating a product, the quotient rule for differentiating a quotient, or think fraction of functions. So let's put these to work for us. Let's start by evaluating, and we'll do so in two ways, the derivative of the given function. So maybe the first observation we can make if we want to differentiate this is you could say it is a function square root x times a function x squared minus 3x. So let's go ahead and just differentiate this using the product rule. So the product rule tells us that dy dx, the derivative of y with respect to x, will be the derivative of the first multiplied by the second plus the first times the derivative of the second. Then we just go ahead and differentiate each of these individually. So remember that the square root of x is really x to the 1/2. So if we want to differentiate x to the 1/2, the power rule tells us that would be 1/2 x, and the new power of x is 1 less. And more conveniently, that's 1 over 2 square roots of x. And that is a formula that we will use commonly. The derivative of square root of x is 1 over 2 square roots of x. And that really comes from the power rule. So the derivative of the first times the second plus the first times the derivative of the second. Just hitting each term with the power rule. The derivative of x squared is 2x. The derivative of 3x is 3. And you could certainly leave your answer exactly as is. Let's give a second way that we could easily evaluate this. So additionally, instead of thinking of it as one function times a second, we could take this square root x and simply distribute it through to each term. So we would have x to the 5/2 minus 3x to the 3/2. With this observation then, dy dx, just differentiating both terms individually with the power rule, becomes 5/2 x to the 3/2 minus 3 times 3/2, so 9/2 x to the 1/2. And remember, there oftentimes might be multiple approaches, and so you have to think sometimes what is going to be the most efficient. Here I think either works about the same, but it's always a good idea to remember that a little bit of algebra, think kind of how we expanded this out, can sometimes go a long way. Next, we will evaluate the derivative of 1 plus sine x divided by cosine x. So from our first or initial observation here, we see a function divided by a function. So let's just write down what the quotient rule tells us and see what we're going to need to end up calculating this derivative. So simply from the quotient rule, dy dx is equal to low d high minus high d low, all divided by low squared. And this is what the quotient rule tells us, but in order to finish this derivative up, we will need to know the derivative of sine. Remember, the derivative of a constant is 0, and the derivative of cosine. And let me just simply remind you of those formulas. So the derivative of sine is cosine, and the derivative of cosine is minus sine. So now kind of cutting and pasting and evaluating derivatives as we encounter them, we have cosine x multiplied by the derivative of 1 plus sine. The derivative of 1 is 0, the derivative of sine is cosine. Then we have minus the quantity 1 plus sine times the derivative of cosine. And the derivative of cosine is minus sine, and this is all divided by cosine squared. And at this point we've finished up the differentiation, but I do see one obvious simplification, so I'm going to go ahead and maybe take this a step further and note that you have cosine times cosine, which is cosine squared. And when this minus sign distributes through, you can think of this minus as pulling all the way out and turning that into a plus. And then the sine distributes. So in the top you have cosine squared plus sine squared plus sine. And cosine squared plus sine squared is 1. So we'll have 1 plus sine all divided by cosine squared. So as a reminder, derivatives that you certainly need to know are the derivatives of the 6 trig functions. I have them all listed here, but also, as an even more important reminder is if you know the first 2, the derivative of sine and the derivative of cosine, one could use the quotient rule to get the remaining 4 differentiation formulas. So you don't necessarily have to have them memorized. Also, an easy way to remember the sine over cosine is I typically find students remember that tangent is sine over cosine. So I start by writing those 2 things down. Then I complete a cycle here. I write minus sine, opposite of sine, and then minus cosine, opposite of cosine. And I think going around here in the clockwise direction, each arrow represents a derivative. So that would be the derivative of sine is cosine is minus sine, etc. Something else to help you remember these formulas, I find students typically struggle the most with the minus signs. Notice the derivative of cosine has a minus, cotangent has a minus, cosecant has a minus. So the derivative of all of those co-functions are the only ones that include a minus in the differentiation formula.